Hello everyone. In this session, we will deal about magnetic lines and its properties. So, first, we will deal with how to draw magnetic lines of force in a lab. Okay, so for that, we need a base for fitting our paper. It can be a wooden board. So, there's a wooden board taken and the paper also taken to draw the magnetic lines of force. You can pin this paper at the four sides and we can place the magnet at the middle of the paper and draw its boundary so that when the magnet gets displaced from it, we can easily put it back into the boundary and start drawing it. So let us start how to draw it. So on the piece of paper, we are placing the magnet with the boundary drawn, and we know that this is the north and this is the south of the magnet. Already it's marked there. We place a compass needle near the north pole of the magnet. So, as already discussed in the last session, our compass box consists of a needle which itself is a magnet. So, what happens is that the north of that needle will be repelled by the north pole so that it will show a direction. So, where is the north shown? We'll put a dot here across the arrow or the needle that is showing in which direction. We will put a dot. Then the next step is to place this compass needle over the dot. So the compass needle will come over the dot. Again it will be with the influence of this north pole. So it will show some direction, and the arrowhead of the needle should be again noted and put a dot on the paper. So we again displace this compass box over that dot. So that again that compass needle of the box shows a deflection. So again we put the dot near it in the direction of the deflection. Then place the compass box again on it like that. And after a series of experiments, we will get a pattern of dots like this. So the pattern of dots look like this after the experiment, so that we can join these dots and draw the first magnetic lines of force. In that way, we can draw numerous lines of force like this of this magnet. But you have to note that whenever we draw magnetic lines, they do not intersect each other. When we do the experiment, we can note it. And while discussing the properties of magnetic lines of force, we can understand that this, as the compass pointer was always showing the north like this, deflecting towards the south, we can put arrows like this on the magnetic lines of force outside this magnet, so that the magnetic field lines around a bar magnet looks like this. A question can be asked to you for drawing the magnetic lines of force of a bar magnet. So how should it look like? If this is a magnet, this is the north pole and this is the south pole. For a neat diagram, you can select only up to some 5 or 6 magnetic lines, so that every magnetic line should run from north to south. Here it is from north to south. Here there are more lines. You have to note that they must not intersect each other like that. Here also the lines must run outside towards this direction and it is ending in this direction. So you can show it like this. It is from the north, and this line may be probably a bigger magnetic line that is ending in the south. So please note the arrow here what I have drawn. So from this diagram, let us discuss. You can join 2 or 3 lines without intersecting at the poles. So now we are going to discuss the properties of magnetic lines of force. So what is it? Properties of magnetic lines of force. That also can be asked as a question. So what is the first property of magnetic lines of force? The first property of magnetic lines of force is they are closed continuous curves. They are closed continuous curves. What do you mean by closed continuous curves? Outside the magnet, they run from north to south, and inside the magnet they run from south to north. Here inside the magnet we haven't drawn because we cannot draw it what is inside the magnet. So what do you mean by closed continuous curves? Magnetic lines of force run from north to south outside the magnet and from south to north inside the magnet. That's why magnetic lines are called closed continuous curves. They are not having a break. So we have to think that it is from south to north inside the magnet. That's why they are closed. North to south outside the magnet and south to north inside the magnet. So what is the first property of magnetic lines of force? They are closed continuous curves. Question can be asked, why magnetic lines are called closed continuous curves? Because they run from north to south outside the magnet and from south to north inside the magnet. Second point is magnetic field lines do not intersect each other. They will not intersect each other. So they do not intersect each other. So what is the explanation for it? They do not intersect each other. What is it? Look, if we are drawing two magnetic lines of force intersecting, at this point we put a compass box. Either the compass box should show in this direction or the compass box should show this direction so that we can continue with these two curves. Suppose we say that this is A and B. A compass box is placed here. The needle should point either to this direction or to this direction to draw these two curves. But you know that at the same time a compass needle cannot show two directions, which is not at all possible. That's why we say that magnetic lines of force do not intersect each other. So why do not intersect each other? Because at the intersecting point, if a compass box is placed, the needle should show two directions at the same time, which is not at all possible. The third property is, we know that near the poles, the magnetic fields are stronger. So, magnetic field lines come closer. They are closer. Field lines are closer where field is strong. And they go farther. Opposite of closer is they go farther where the field is weak. So this is the third point. Magnetic field lines are closer where the field is strong. Here we see so many closer lines because at the poles the magnetic field is strong when compared to other areas around the magnet. So field lines are closer where the field is strong and field lines go farther where the field is weak. And of course, when we come to the fourth point, magnetic field lines give the direction of the magnetic field. That means if you want to find the magnetic field at this point, we just draw a tangent. So the tangent to the field line at any point gives the direction of the magnetic field. So we can write tangent at any point on the line shows the direction of the field. So magnetic field line can be used for getting the direction of the field. So what are the properties? Once again, you are coming to the conclusion. What is it? Properties. They are closed continuous curves. First point. So half, 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 half. It can be a 2-mark question also for you. So what is it? They are closed continuous curves. That is, they run from north to south outside the magnet and from south to north inside the magnet. That's why they are called closed continuous curves. They do not intersect each other. Why they do not intersect each other? Because at the intersecting point, when a compass needle is placed, it will show two directions, which is not at all possible. Field lines are closer where the field is strong and farther where the field is weak. And the tangent at any point to the field line gives the direction of the field. These are the properties of magnetic lines of force. Hope you understood.